synthetic division in the remainder theorem. So if this function is written as so, determine the remainder when it's divided by x plus 2. So you can plug in a negative 2. So negative 2 to the 5th minus 12 times negative 2 plus 1. So if you just plug that in, it would equal negative 7 on the math. Or you can synthetically divide. So a negative 2 in the front, 1 for a 5th, no fourths, no cubes, no squareds, negative 12x, and a 1. Bring this down, 1, multiply, add, multiply, multiply, add, multiply, add, multiply, add, multiply, add, and then my remainder is negative 7. Given that this is a factor expressed as a product of factors, okay, so I'm going to go 1 divided by 1 for a cubed, no x squareds, negative 57x, and 56 is the number. So synthetic division, pull that down, 1 times, add down, times, add down, times, add down. So now this would be x squared plus x minus 56. So that's that. We still have times an x minus 1. And then I'm going to break this down. What multiplies to 56? So that would be 7 times 8. So that's my product of factors. Is this a factor, justifier, or not? So 2 ways. Remainder theorem, you could plug in a positive 3. So you can replace every x with a 3. And doing your math equals 29 when you type that into your calculator. So no, it is not. The reason is that the remainder does not equal 0. You can also do that with synthetic division. So you would put a positive 3 in the front, 1 for the 4th, negative 1 cubed, negative 3 squared, 1x, and a negative 1. So bringing that down, 1, multiply 3, add 2, multiply 6, add 3, multiply 9, add down, multiply 30, which is 29. So same idea. No, the remainder is not 0. Given this is a factor, which of the following is true? When x is negative 3, y would be 0. If x is 0, y would be negative 3. If x was 0, y would be 3. If x is 3, then you would get a 0. So this would be true, because this makes an x-intercept, in other words, that. So remember that this is negative 3 is the input x. One of the factors of that is negative, or x minus 2, so find the value for k. So if it is a factor, the remainder should be 0. So 0 equals, so I'm going to plug a 2 in, 2 cubed minus k times 2 squared minus 7 times 2 plus 10. So this would be 8 minus 4k minus 14 plus 10. So I'm going to put those numbers together. So that would make 4. And then if I move 4k over, k would equal 1. I can also do this with synthetic division. So I'm going to put a 2 in the front. I'm going to go with a 1 for a cubed, a negative k, a negative 7, and a 10. I know the remainder is 0. So we're going to go here. So this would be a 1. This would be a 2. Now this would have to be a negative 10 here to make 0. So I would need a negative 5 there to multiply to that. And what to add to that? I would need a 2. What to multiply to get the 2? A 1. And then what do I need in that spot? I need a negative 1 plus 2 to add. Therefore, k is 1. So when the function is divided by x plus 3, it has a quotient and a remainder of 4. Determine p of x. Okay. So if I put a 3 in the front and we have a cubed, squared, x, and a number. And we have a remainder of 4. We know that it has a quotient 2, 1, negative 6. Okay, so we must have pulled down a 2 to make that happen. That multiplies to 6. So this must be a negative 5 to make sure we add to 1. Now 3 times 1 is 3, so this must be a negative 9. This multiplies to negative 18. Therefore, this would be 22. So p of x equals 2x cubed minus 5x squared minus 9x plus 22. Determine the remainder when this is divided by that. So I'm going to go 2 ways, synthetic division or remainder theorem. So negative 2 in the front, 1 for a fourth, no cubes, negative 3 for squareds, no x's, and 1. Bring that down, multiply, add, multiply, add, multiply, add, multiply, add. So I'm getting a remainder of 5. We'll do it the other way. So we're going to go negative 2 plugged in, which makes also a 5. So remainder of 5. Is this a factor? So it's not a factor, and your reasoning is that the remainder does not equal 0. Divide. So negative 1 in the front, 1 for a cubed, no squareds, negative 5, negative 4. Bring that down, multiply, add, multiply, add, multiply, add. So I'm not sure if they want a division statement here, but we can say that this polynomial divided by this polynomial equals x squared minus x minus 4. Number 9, is this a factor? So we could do 2 things. We could plug in a 2, so negative of 2 to the 4th, plug in a 2, and when you do that in your calculator you get a 0, so the answer would be yes, it's a factor. because the remainder does equal 0. You could also do it with synthetic division, so a positive 2 in the front, negative 1, negative 3, 11, 3, and negative 10. Bring this down, multiply, add, multiply, add, multiply, add, multiply, add, and then you can see your remainder is 0. Determine all the zeros of this function given one of the factors is x minus 3. So I'm going to put a 3 in the front. Cubed, squared, x number, that's good with the order. Let's bring this down 1 times, add, times, add, times, and add. We knew that should happen. So this would be 1x squared minus 2x minus 8. And then we can't forget that we still have that as a factor. So I can try to break that down by hand, and I'm going to say p of x equals x minus 3 multiplies to 8, 4 times 2, okay, so that's the equation, but now it says determine all the zeros, so we actually haven't answered the question. So the x-intercepts are 3, 4, and negative 2. A student must determine the factors. He used all those as the coefficients when doing the synthetic division. Explain his error. So 5 would be to the 4th, negative 2 cubed. They need to have a 0 in that spot. So the student forgot the order, was missing an x squared, so place a 0. Obviously I can show you right there. Given that that's one of the factors, express it as a product of factors, so synthetic division with a negative 3. 2 for cubed, 7 squared, 2 for x, negative 3. So bring that down, 2, multiply, add, multiply, add, multiply, add. So x plus 3 was already a factor. Now this is 2x squared plus 1x minus 1. Now we can break this down by hand, 2x and 1x, and then multiplies to 1, 1 times 1, plus minus. So there is the product of factors. Okay, number 13, given that polynomial, if you plug in a 1, it equals 0. Identify which statement is true. So this would be the x-intercept is 1, which would also mean the factor is x minus 1. So I would know those things right away. So this statement, nope. This, nope. The graph has a 0 at 1. That would be true. Okay, determine the value of k. So we could do this algebraically or synthetic division. So algebra would be the remainder is 8 when you would input a negative 2. So I'm going to simplify all these number values here. So that's a 48. This would be negative 8 and then a negative, so plus 8k minus 10 minus 14. I'm going to put those three numbers together. So that would be 24. moving the 24 over makes negative 32. So k equals negative 4. I could do this with synthetic division. So I'm going to put a negative 2 in the front. 3, negative k, 0, a 5, and a negative 14. And the remainder was negative 8. So bringing this down is 3. Multiplying was negative 6. I can't do anything there. So now I'm going to work backwards. So this would have been a 6 here to get that. What times is to get that? So negative 3. What do I need in here to add? I would need a negative 8. And then this multiplier would have been a 4, which makes this a 4. What multiplies to make the 4? Negative 2, which means in this position I would have needed a positive 4 in that position, which makes, so negative k equals 4, so therefore k equals negative 4. It's a little bit tricky because it's a negative k, so you kind of got to do the opposite. Using the remainder theorem, identify which value of x results in a remainder of 0. Okay, so we can plug these values in. 1 cubed plus 7 times 1 squared. So this is the remainder theorem, so you can't use synthetic division on this. So algebra, does that equal 0 or not? Nope. For b, I already know if I input a 0, it's going to be 8. So nope. C, if I plug in a negative 1, so all you're caring about is if it equals 0 or not, and this one on the calculator does. One of the zeros is x equals 2. Determine all the other zeros. So 2 is a 0. 1, 6, negative, oh, I need a 0 there for x. Cubed, squared, no x's, and negative 32. Bring that down. 2, multiply 4, add 10, multiply, add. Nope, something's wrong here. Sorry, why did I pull down the 2 here? There we go, fixed it. That multiplies to 2, which makes 8. There we go, which makes 16, which adds to 16, multiplies to negative positive 32, which adds to 0. Because I did know that's supposed to come out to be 0 there. Okay, so now this is x squared plus 8x plus 16. And then we also have an x minus 2 as another factor. And then this breaks down to be x plus 4, x plus 4. So what are all the zeros? The zeros are 2 and negative 4. It'd be a double, it'd be a bounce, right? Okay, express as a product of factors, so we don't know anything, so we're going to have to run some tests. I'm going to test 1. 1 cubed minus 2 times 1 squared minus 4 times 1 plus 8. Does it equal 0 or not? So 1 minus 2 minus 4 plus 8. That is not 0. I'm going to run 2 cubed, just plugging it in. So this is 8 minus 8 minus 8 plus 8. Okay, that equals 0. So I found an x-intercept. So 2 can go in the front. 1, negative 2, negative 4, and 8. Bring that down, times, add, times, add, times, add. Okay, we should come out with a 0 there. So this should be x squared plus 0x minus 4. And we already had an x minus 2 because of that x-intercept. And my final answer, I'm going to break down a difference of squares here. You can also, if you want to put those together, you can also make that your final answer. Either one is fine. When a polynomial is divided by x minus 2, this is the result. Explain why it's not a factor. Because the remainder equals 3, which is not 0. Determine the equation for the polynomial. Okay, so if I'm dividing by x minus 2, there would be a 2 there. So this would be a cubed, because the division result was a squared, so it starts as a cubed. Okay, and then I knew the remainder was 3. The quotient was 1, negative 1, and 1. So here I would have had a 1. This times is to 2. So what would be my adder there? So negative 3. This would times to negative 2. So I would need a 3. And then this times is to 2, so therefore I would need a 1. So my original equation p of x would equal 1x cubed minus 3x squared plus 3x plus 1. Determine the zeros. So we don't have any, so we're going to test. Let's test 1, 2, 1 cubed. Just plug in a 1 and see what happens. So this is 2 plus 5 minus 4 minus 3. That equals 0. Okay, so I'm going to do synthetic division. 1 on the outside. Cube, squared, x. So good with the order. Bring that down. 2 times 7 times. So that's 3 times and add. Okay, so this is 2x squared plus 7x plus 3. And don't forget, we had x minus 1 in the front. And then this can break down by hand. So 2x, 1x, 3, and 1 to make 6, 1 with a 7. So this asks for the zeros. So 1, negative a half, and negative 3. Given that that's one of the factors, express completely factored. So synthetic division with a negative 4. So 1 with the cube, 6 squared, no x's, and then the number. Bring down, times, add, times, add, times, and add. So this would become x squared plus 2x minus 8. And then we also had an x plus 4. And this is called p of x. And then this I'm going to break down. So x plus 4, x minus 2. Or you could have done the x plus 4's squared because you have a repeat Okay, number 21. When a polynomial is divided by this, the remainder is 24. Identify the only statement that must be true. So if the remainder is 24, I know 7 is not an x-intercept. I would know that. X equals 7 is a 0, so no. When you plug in a 7, you get 24. That would be true. When you plug in a 7, you're going to get 24. X equals 24 is a 0. That's definitely not true. And the y-intercept is 24. It's not true. Determine algebraically all the zeros. Okay, so right away I actually can factor out a GCF. So I'm going to go x bracket, x cubed, take out an x. Okay, now I'm just going to be looking at that piece and trying to break that down. So now I'm going to test 1, 1 minus 5 minus 4 plus 20, that does not equal 0. I'm going to test 2, so 2 cubed, okay, so we get 8 minus 20 minus 8 plus 20, that would make 0. So I'm just going to take this piece, forgetting about that now. So a 2 worked, so 1 for the cubed, negative 5, negative 4, and 20. Bring that down. Whoops, I keep doing that. 1 times is 2, times, add, times, and add. Okay, so now this is x squared minus 3x minus 10. Now we have this, which is x minus 2, and we had the GCF to x. Now this breaks down, x minus 5, x plus 2. So the zeros are 5, negative 2, positive 2, and 0. Identify the remainder, so you could plug in a positive 2. So that equals 21. You could have also done synthetic division with a 2, and then this would be a 3, negative 1, 0, 1. Bringing that down, times, add, times, and add, and you can get to the same thing. Justify that this is not a possible factor of the function, so we could plug in a 5, 1, negative 3, negative 4, and a 12. The order is good. 5, 2, 10. This would add to 6, multiply to 30, adds to 42. The remainder does not equal 0. Or you could insert a positive 5. And the remainder equals 42. So the remainder does not equal 0. Given that this is a factor, determine the value of k. So we can go algebra or synthetic division. So algebra would be, well, one of the factors, so the remainder is 0. So 0 equals, I'm going to plug in a negative 1. So the math on this is negative 1. This is positive 1, but we're going to subtract. Minus k minus 8. So all that makes negative 10 minus k. If I move the k over, k equals negative 10. Synthetic division way, you could go with a -1 on the outside, and then this would be a 1, -1, a k, and a -8. The remainder was 0. Bring this down 1, -1, add, multiply. Can't go any further there, so this, I'm going to go here, is an 8. So what multiplier do I need here? -8. Therefore, what do I need in that position? A -10. When this polynomial is divided, remainder is 17, identify which statement is true. So x equals 4. So if you plug in a 4, you would get out a 17. Okay, express completely factored. So I'm going to synthetically divide with a -3. Cube squared x number. Good with the order. Bring that down, 1, -3, -1, +3 times, -2 added, +6, 0. This would be 1x squared minus an x minus 2. And then we also have x plus 3. And then I'm going to factor this trinomial, so x with a 2 and a 1. I need a -2 and a +1. Number 28, given that x equals 3 is 0, express in completely factored form. So I'm going to put a 3 in the front, 1 with the cube, there's no x squareds. Bring this down, 1, multiply 3, add 3, multiply 9, add 2, multiply 6. So this is a 1x squared, a 3x, and a 2. We already have x minus 3 as a factor, and this is called p of x. So this can factor x plus 2 and x plus 1. Determine the remainder when you are dividing. So this could go plugging in a -3. So just plugging that in. So when I plug that in, I get 0. And you could have done that also with synthetic division. So that would look like a -3 out front, 3, 5, -13, -3. Bringing that down, multiply, add, multiply, add, multiply, add. Same thing, remainder is 0. Is this a factor? Your answer is yes. And the reason is the remainder equals 0.